Okay, so let's look at your orange reference sheets, and I want you to flip it over to the back. So we haven't gone through all of our trig identities, and we still have a few days to go. Your test on this is not for a couple weeks, but we're going to introduce proofs first before we finish them. So I'm going to read through your proof tips on the back, and I'm going to point out some of the things on here that I think are going to be most helpful to you. So here's basically what you're going to be getting yourself into. Your first proof for today is going to look like this. It's going to say, prove that the secant of theta, you don't need to write this down, minus the tangent of theta is equal to 1 minus sine theta over cosine theta. So you have to prove that these two things are equivalent to each other. And yesterday, those of you that were here and actually listened, you opened up the back of your textbook and you saw what sample answers look like for these proofs. Okay, so some of the important things. Proving trig identities involves transforming one side of the equation into the same form as the other side using basic trig identities and the properties of algebra. Okay, one way to write a proof is to continue to write equivalent expressions for one side of the equation until you get an expression identical to that of the other side. You can transform one side or both sides, so it just depends. So here's my biggest suggestion. We're going to do this every single time today. Whenever you get a proof, I recommend that you're going to transform or simplify the more complicated side first. And if that doesn't get you anywhere, then you can kind of do, something to the other side. But always take on the more complicated side. You can also substitute one or more basic trig identities to simplify. You could factor or multiply to simplify. You could multiply both the numerator and denominator by the same trig expression and see what that gets you. This is one of the most important things for you to understand. Proving an identity is not the same as solving an equation. The vertical line separating the left and the right side of the equal sign cannot be crossed. Each side is to be simplified independently of the other. And here's what I mean. Even though I mentioned using algebra for a proof for this equation that I have here, you cannot do things like add tangents to both sides. Okay, that's not allowed. So you are not allowed to do algebra. You're not allowed to cross over that equal sign to the other side. You can do algebra on one side independently of the other for a proof. Okay, so it's not like solving. It's not like getting x by itself. It's a little bit different. So here are some strategies. Number one, know the fundamental identities and look for ways to apply them. Now, of course, I had multiple people ask, do we have to memorize the identities? The answer is going to be no. I don't exactly know how, if I'm going to provide them to you or let you use your reference sheets or whatever, but I'm more concerned that you are able to know when and how to use your identities rather than memorize them. Okay. Two, you might write all expressions in terms of sines and cosines. So sine and cosine are, I will say that maybe the more frequently used trig functions, or that every other function can kind of relate back to those. So that's a suggestion. If you choose to work with one side, make sure you refer back to the other side often. Number four, when one side has only one trig function, try to rewrite all of the other functions in terms of that one. 5, use Pythagorean identities to substitute for expressions equal to 1. And then number 6 just goes through some algebraic things that you can do as well. So let me ask you this. If I gave you 3x plus 18 is equal to 10 plus 12x, how many of you would subtract 3x from both sides? Okay, how many of you would subtract 10 from both sides? Okay, what about subtracting 18? Would anybody do that? I mean, probably not. Could you do that if you wanted? Yeah, sure. And same thing, I could subtract 12x, but you and I are good enough at algebra now to know we can kind of see one step ahead that me subtracting 12x from both sides is going to get me a negative x, and, not that that's wrong, it's just not as pleasant. Let me ask you this. What if I divided everything by 3? Could I do that? I could. If I divided everything by 3, what do I get? 10/3 plus 4x. Is that, something that you should do? I mean, probably not. There is no right or wrong answer, but for some people that complicates things, and it kind of would take you longer to solve the problem by just doing that random step. So that's what you need to understand today about our proofs, is that there are going to be so many things that you could do and a smaller handful of things that you should do that could actually be beneficial to you. And the issue is that we're pretty familiar with algebra now, but we're not as familiar with our trig identities and using algebra with the trig identities. Something else to keep in mind. If I said, all right, everybody, go to the student parking lot and get in your car, and I want you to meet me at the mall. Some of you are going to speed and break rules, and you're going to get to the mall very quickly. You can't break rules. That's my showing your every single step in a proof. You have to show every single step. You cannot skip anything or cheat yourself out of anything. Some of you, when you leave the parking lot, you're going to go left and take Buddy Gannum to 181. Some of you are going to take right and take Wildcat to get there. No one is more right than the other. It's just the way that you try to get to 181. Some of you may stop at your house on the way to get some money. So you're going to delay yourself a little bit to getting to the mall. I need you to be patient with yourself. I've had lots of frustration this morning from people because, some of this is really difficult. And the hardest part, Mr. Ware and I keep saying for some people, is that there's not one correct answer. Grading proofs is going to take us a long time because there's not one like, oh, they got down to x equals 7. Awesome. And their work looks like it makes sense. Great. I literally will have to follow logically every single one of your steps to make sure that what you did to get from one to the other is legal, mathematically legal, I like to say. Okay, so be patient with yourself. I know y'all have a reputation for being the sleepy sloths after lunch, but today is not a great day to let your sleepiness and exhaustion take over. It would be a great day to tune in, ask questions, and the big thing, guys, is just to try. It's to try. I'm going to ask you for suggestions. I'm going to say, hey, what do you think is something that we could do here? And I want you to just tell me literally, what are you thinking? And some people have said, oh, I don't know if it's going to help, but what if we did this? That's the attitude that you need to have, is I don't know if it'll get me very far, but what if we tried this? Okay, so let's do that question that I wrote up at the top. I want us to prove if secant theta minus tangent theta is equal to 1 minus sine theta over cosine theta. Prove if secant theta minus tangent theta is equal to 1 minus sine theta over cosine theta. And of course, as we go through some of these examples, I'm going to give you some hints and suggestions of some tactics using the list that typically help you progress throughout a proof instead of kind of like spinning your wheels and going backwards. This one, though, I'm always going to ask, which side appears to be more complicated to you? Right. Anytime that there's like fractions, that's typically the more complicated side. So what I want to do is I want to leave the left side alone for now. So I'm going to leave the left side as secant theta minus tangent theta. If the vocabulary of the question says prove if these are equal, then I'm going to put a small question mark above my equal sign because I don't know if they are equal. I'm trying to prove that they are. So I'm going to carry that question mark down my proof. Okay, I want to do something to my right side. I want to try to get this equivalent to the left side somehow if possible. Does anybody have any thoughts? This is something we could do. Okay, so maybe it's good that you see sine over cosine is tangent. So what if we break up this fraction? Are we allowed to break up that fraction into two fractions, one being 1 over the cosine of theta minus sine theta over cosine theta? Is that mathematically allowed? You sure? Okay, let me ask you this question. What if it were opposite? What if I had cosine theta over 1 minus sine theta? Could I? I cannot do cosine over 1 minus cosine over sine. This is not mathematically correct, and this is important, and some people try to do this and they fail. Okay, if your denominator is a binomial or more, you cannot break it up into multiple fractions. Because our denominator is a monomial, we can. And guys, if you ever like struggle with that, plug in numbers and ask yourself, am I allowed to do that with numbers? So like the one that we're actually going to do in the proof, maybe I do 12 minus 10 over 2. I want to know, is this the same thing as doing 12 over 2 minus 10 over 2? Well, what is 12 minus 10? And we know that it is 2, and then we know 2 over 2 is 1. Is this the same as doing this? What's 12 over 2? 6 minus 10 over 2 is 5, and yes, 1 is equal to 1. So if you ever struggle with, am I allowed to break up a fraction a certain way, plug in numbers and see if it's true. So what we've done here is perfectly mathematically legal. Okay, so now let me leave my left-hand side alone, secant of theta minus tangent of theta. And now let's use some identities. What is 1 over cosine? It is secant, right? Using our reciprocal identity. And as Tyler said earlier, he noticed that sine over cosine is tangent using one of your quotient identities. And look what you've just done. You've just proven that secant theta minus tangent of theta is equal to secant theta minus tangent theta. When that happens, you will put a little box at the end of your proof to show that you were done, and your last step no longer needs the question mark symbol over the equal sign because you've proven that they are indeed equal to each other. Okay, the only thing that I would do, and I'm going to erase my random math over here, anytime that you use an identity, you don't have to tell me what identity it is per se, but out to the side, I would go ahead and write identity. Just so that your reader of your proof kind of knows what you're doing beyond basic algebra. And that kind of relates back to the 2-column proofs that you probably did in geometry, where you had statements on the left side and reasons on the other. I wanted to, reiterate that your whole answer is the problem itself. So you don't need to box a final answer. You need to just put a little box at the end to show that your proof is complete. Okay, let's do another one. I want you to prove if 1 plus tangent of theta over sine theta plus cosine theta is equal to secant of theta. 1 plus tangent of theta over sine theta plus cosine theta is equal to secant of theta. Bless you. Bless you. Okay, anytime you approach a proof, I would always simplify the complicated side first. I had some people say, oh, on the right-hand side, the sine, or the secant. I know the reciprocal of secant is cosine, or 1 over cosine, so maybe I'll switch it to that. I wouldn't do that, because then you're going to complicate the easy side. You want to try to simplify the complicated side first. Does anybody have any ideas of what we can do to the left side to try to simplify it or break something down or what? Multiply the whole thing by tangent? So here's the deal. You can't multiply it by tangent. You could multiply it by tangent over tangent if you wanted, because that's just the number 1. Right? And if I multiply something by the number 1, I'm not changing it. But you can't just multiply by something that's going to change its truth value. But I like what you're thinking. Why were you going to say that, Zach? Well, how would that help you? Okay. Okay. So same thing. if you multiplied by tangent over tangent, that's a possibility. But then I'm wondering if that would help you, because then in the denominator you'd have tangent sine plus tangent cosine. So I don't know that that would help. Or I don't know, you would get there eventually, but it might take you a little while. I'll give you a hint from our proof tips. One of the things that's also going to be useful that I said was if you convert everything into sines and cosines. So on the left-hand side, the only thing that's not in terms of sines and cosines is tangent. How else can I rewrite tangent? Sine over cosine. So let's do that. So I'm going to do 1 plus, I'm going to change tangent to sine over cosine, sine theta over cosine theta. And I'm going to put all of this over sine theta plus cosine theta. I'm trying to prove, is this equal to secant of theta? So at first it kind of looks like I muddied the problem up a little bit, but I didn't. You'll see here in a second, it'll simplify very, very nicely. Another suggestion that was on your proof sheet was to basically multiply the numerator and denominator by the same trig expression to try to get rid of your fractions, to try to get rid of your rationals. So how could I get rid of sine theta over cosine theta? What could I multiply that by so that it's not a fraction anymore? Yeah, if I multiply, and here's the other thing. When you do that, in order to show that you're changing one thing at a time, you want to recopy the step that you currently have before you show that that's what you're doing. And again, this is not me picking on you, asking you for step by step. This is just how you have to write proofs, is changing one thing at a time. So Zach's suggestion, and I like it, is what if we multiply the left side all by cosine theta over cosine theta? All right, and this is just the number 1. I'm not changing the value of something if I multiply it by the number 1. So I'm going to multiply that fraction by the fraction that already exists. Okay, when I do that, the rule is that we have to multiply fractions. Oh, and side notes. Up here, I could have written the word identity because I changed tangent to sine over cosine using the quotient identity. Okay, when I multiply these cosines straight across, they're going to distribute. Okay, so when I distribute this cosine, so 1, I just get cosine theta. And then cosine theta times sine over cosine. What is that? It's just sine theta. Okay. From this point, you could do 2 things. If you see something right now, you could not distribute. If you have a hard time seeing something, then I would just go ahead and distribute this cosine as well. So if and let me do that because I think most people aren't going to see it yet because y'all aren't great at proofs yet. If I distribute the cosine on the bottom, then I get cosine theta times sine theta plus cosine times cosine is cosine squared theta. Now, it looks like I made this a little bit complicated. But is there anything that you noticed that I could do? Yeah, what if I factor out cosine theta in the, well, hold on. Were you saying factor or were you trying to say cancel those front cosines? Were you just saying that I could, like, do this? Ashley, is that you talking, by the way? Were you saying that I could just do that? Okay, yes or no? Okay, were you saying factor one of the cosines out in the bottom? Yes, okay. I'm just trying to clarify. Let's do that. If I do that, if I have cosine theta plus sine theta in the top, and thank y'all for bearing with the blinky screen, by the way. cosine theta plus sine theta in the top. If we take Ashley's advice and we factor out cosine in the bottom, which again, I'm kind of going back a step, right? Because if I didn't distribute it, this is what I would have. Then I have sine theta plus cosine theta. Now what do you see? Yeah, well, other than that cosine on the outside, right? I know cosine plus sine is the same thing as sine plus cosine. So if those two things cancel, I hate to use that word, but that's true, what is left? 1 over cosine. And then what? Yeah, then the reciprocal identity says 1 over cosine is secant. So then secant of theta is equal to secant of theta using my reciprocal identity. And I started to write it, but you don't need the question mark symbol anymore because you've proven that it was true. So this one's a few more steps than the first one. Does anybody have any specific questions about any of the steps that we took? Matthew, how's your brain doing? Good. Okay, I'm just checking on you. You're usually kind of vocal, so I want to make sure that you're doing okay over there. Right, and again, that's the difference in questions. In your homework, you know, it gave you something and it said using this find something else. So in that's you need to show your work for our sake, right? Of checking your answers and making sure that we know that we can understand how you're getting there. But in a proof, there you cannot take shortcuts. Right. And you also cannot use something unless it has already been proven. So you remember the first day that we learned all of these identities, you proved those identities based on what you knew about the Pythagorean theorem and about your trig definitions, right? Sine being the same thing as opposite over hypotenuse being y over r. Like all of these identities you derived already, which is the only reason you're allowed to use them now. Okay, so here's your next one. Prove secant squared theta minus 1 over secant squared theta equals sine squared theta. So this one has a few different things that you could do. Does anyone want to take a stab at something? Negative 1 over secant squared theta. Whoa, wait, say that one more time. Oh, okay. Just like we did in the other one. So secant squared theta over secant squared theta minus 1 over secant squared theta, like this. Okay. And we want to know, is that equal to sine squared theta? Okay, I like that. And that's just using a basic mathematical property of fractions and addition. So you don't need to write a reason out to the side for that one. Okay, so now what? What is secant squared theta over secant squared theta? Just anything divided by itself is 1. And then what is 1 over secant squared theta? Cosine squared theta. And there you definitely want to write identity. And by the way, that identity is technically that cosine is equal to 1 over secant, but that implies that it also works for squares. Cosine squared is the same thing as 1 over secant squared. Okay, and that we want to know, is that equal to sine squared theta? Okay, so what does that Pythagorean identity say? Yep. Fabulous. So here's the deal. You need to exactly what you just said out loud. You need to show me that. So you're not allowed to use algebra in your proof itself. Excuse me. Because that's in basically like proof no land. Like you can't. You cannot cross the threshold of this equal sign and saying, oh, I know if I just kind of added cosine, then those would be true statements, or I can't substitute in something that I've not proven. So basically, off to the side, what I would want you to do is I would want you to write that Pythagorean identity, sine squared plus cosine squared equals 1. And then you could say that implies using algebra with the identity that if I subtracted cosine from both sides, then that would mean that sine squared theta would equal 1 minus cosine squared theta. Okay, so you can do that algebra off to the side. Then when you do that, you have two choices. You can either substitute 1 minus cosine squared theta to be sine squared theta, and then you can say sine squared theta equals sine squared theta, and you're done. Or you could use the same trig property to have substituted for sine instead and had your final statement be 1 minus cosine squared theta is equal to this 1 minus cosine squared theta, and end your proof with that statement. So either one of these final statements would be fine using that identity. Questions, thoughts, comments, concerns? Okay, do you have one on another one or just in general? Yes. Okay. Okay. Was cotangent squared, right? Oh, I thought you said cosine squared over sine squared. Okay, go ahead. So that, yes, that would be cotangent. Yep. Yeah, absolutely, because cosine over sine is cotangent. So that's just using that trig identity. Oh, hold on. So it says cosine over sine plus 1 like this. Yeah, this would be cotangent. Oh, no. Yeah, you cannot break that up. I'm sorry. I thought that plus 1 was out to the side. No, nothing. You can't break that up. Nope. And again, pick numbers if you want to. Right? Like, ask yourself, if I had 10 over 5 plus 2, is this the same thing as doing 10 over 5 plus 10 over 2? So that route wouldn't work, but something else definitely would have. And if we have time, we might even get to that particular question. Okay, go ahead. Oh yeah, that's the key, is you have to not be afraid to try something and kind of go in circles for a second, or try something and go, nope, that got me nowhere, so let me back up. Okay, let me do another one. What about that has like fractions in it? Yeah, I haven't done one yet. Oh yeah, actually we're gonna do one. Yeah, is that number 6? Yes, that's the first one on your homework. So once we get through the examples that I have, we'll start on that one. Okay, let's do another one. Let's prove. I'm going to change the vocabulary a little bit for this problem. I want you to prove that, and the only word that I'm changing is if to that, secant squared theta minus tangent theta cotangent theta is equal to tangent squared theta. So this one's a little bit different. I'm claiming that these things are equal, and I want you to prove how. So the only thing that's going to be different is that instead of putting the question mark over my equal sign, I'm just going to have equal signs the whole way through because I'm claiming that they are true, and I want you to just prove it. Let me rewrite it. Sorry. Ha 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 ha. Secant squared theta minus tangent theta cotangent theta. So tangent theta, cotangent theta are being multiplied times each other. Okay. A hint that is in your proof tips is obviously start with the more complicated side, which I agree is the left side, if you agree. And another thing is, it says try to get everything in terms of the trig function that you already have on the other side. So like my other side is tangent. So what if I try to get everything on the left side equal to tangent? So I'm not saying change everything individually. I'm saying try to simplify some things to get tangent. Can someone tell me what is the relationship between tangent and cotangent? They're reciprocals. Go ahead, think out loud. Correct. So the only thing that I would want to see in doing that is this step here. Secant squared theta minus tangent theta. Instead of cotangent, I want to see you rewrite cotangent as 1 over tangent theta equals tangent squared theta. So that one step, shows that you know that they are reciprocals and that they will cancel to the extent that it leaves us with secant squared theta. What? Tell me what comes next. Minus 1, very good, equals tangent squared theta. And then when you get to this, that should, and again, we used an identity here. We used a reciprocal identity. And then Zach says, oh, this is one of the Pythagorean identities as well. Which one? Tangent squared theta plus 1 equals secant squared theta. Since that identity cannot be directly substituted in the way that we know it, the way that it is written, on the side, you need to show the algebra that goes behind that Pythagorean identity to finish your proof. So on the side, that identity, if we go ahead and subtract 1 from both sides, then that implies that tangent squared theta is equal to secant squared theta minus 1. Now, you can do just like we did last problem. You can either change secant squared theta minus 1 equals tangent, or tangent squared equals secant squared minus 1. So either one. So I'm going to say after that, then tangent squared theta equals tangent squared theta. And now I have my equivalent statements, so I am done. Okay, I'm going to do one more and then we'll start on your homework. Example. Go ahead. I mean, like over here on the right side, I didn't show, ooh, -1, -1. Like, I'm not talking about that kind of showing work. I'm saying, yes, that I need to see this. I cannot just see you go straight from here to here with nothing else. Because I need to know that you know why secant squared theta, and it's not even me. I shouldn't say that. Actually, I'm kind of bending the rules. I told this to first period. Some math professors would not even allow you to manipulate the identity. They would make you rewrite secant squared theta as tangent squared theta plus 1. And then if you had tangent squared theta plus 1, then this 1 minus 1 would cancel, and then you get tangent squared equals tangent squared. So I'm already kind of bending by allowing you to do algebra with the identity. So if I'm going to allow you to bend, then yes, I have to see, the process. Did I kind of answer your question, Tyler, or complicate it more? Yes. When in doubt, write it out. Okay, one more and then we'll do homework. Prove that sine of A over cosecant of A plus cosine of A over secant of A equals cosecant squared A minus cotangent squared A. Okay, do you agree that both sides are equally complicated? Sure. I mean, they don't have to be, but I kind of think they are. So what I mean is you can start on one side, but you may cross over to the other side and have to manipulate some of that as well. So does anyone have a suggestion of what we could do? What? Okay, I need to see how you know that. So that's what I mean by not skipping steps. Okay, right. So you need to show me that you know. I like where you're thinking. Sine A plus cosine of A. So what Tyler's suggesting is if we change cosecant and secant to be 1 over sine A and 1 over cosine of A. Again, the vocabulary says prove that, so I don't need question marks over my equal signs. Cosecant squared A minus cotangent squared A. And then sine A over 1 over sine A, when I divide by its reciprocal, that's actually, when I divide by a fraction, it's multiplying by the reciprocal. So this is actually sine squared A plus cosine squared A equals cosecant squared A minus cotangent squared A. And again, over here we used the identity. You could put ID for identity too if you want. I'm good with that. Okay, now what? Cool. So that simplifies the left side real nice. Using the identity. So cosecant squared A minus cotangent squared A. But now, so this was an identity. But then what can I do with the right side with cosecant minus cotangent, or cosecant squared minus cotangent squared? Another Pythagorean identity, right? Which says that 1 plus cotangent squared A equals cosecant squared A, right? Okay, so let me show you not manipulating it. That identity would then say that 1 equals, since it's already solved for cosecant, then instead of cosecant, we can substitute in 1 plus cotangent squared A, right? Cosecant is equal to this. minus cotangent squared A. And then what? Say again? Yeah. Cotangent squared A minus cotangent squared A is 0, and then I get 1 equals 1. Ta-da! So this is what not manipulating the identity looks like, and just plugging in straight for what is already solved for the equal sign. Okay, any questions on anything we've done so far? And right, right. And look, so like what you did on the first section is you knew nothing about proofs, right? So you just kind of did that using your basic knowledge of what you've been doing with math in school, like up until now. This is just the nature of proof. It's not a nature of solving a problem anymore. That's why you just have to learn kind of what a proof is and how you have to go step by step in the same silly peanut butter and jelly example that I asked you earlier, right? You have to say silly things like, "Oh, you now need to open the peanut butter jar and then stick the knife in and get peanut butter on it and then spread it on your bread." And are some people going to be even like more anal and say, your brain muscles should pick your hand up and pick up the knife, and then, that's getting a little kind of overkill. I will say your proofs have to have every single step. And when in doubt, like if you feel like you're doing something in your head, just write it down. So proofs are going to be graded extremely strict because that's just what proofs are. If you're going to, yes. One. Oh, I see what you're saying. I see what you're saying. Yeah, I mean, that's going to be pretty sure. Here's the other thing. If we're going to grade every single proof, it's going to take a ton of time. So that should kind of give you the confidence that, like, more, I will go ahead and confidently say most of this assignment will be graded on completion, because if we graded it on correctness, it would take us like 5 days to grade everybody's. Yes. No, not necessarily. I mean, do you do some proofs in calculus? Sure. But this is math in general. I mean, I told you about proving, I need to go find it. It's in a box somewhere. But Tyler was asking about, I had to prove that 2 plus 2 is equal to 4. And it was not just, oh, like Shiloh has 2 cookies and Carlos has 2 cookies, and together we count 1, 2, 3, 4 cookies. Like it's going through the most basic axioms of math, about numbers and integers, and proving their properties. Just like, do y'all know who Euclid is? Do you know? Yeah, Greek mathematician. Do you know where geometry came from? Did you say Pythagorean or Pythagoras? Oh, that guy. Yes, good answer. That guy. Euclid came up with 5 axioms, and all of geometry is built on those 5 axioms. One of those axioms, and this is just things that like they can't be proven. They're just postulates. We just accept them for what they are. One of them is that like 2 points determine a line. Simple, right? Like 2 points determine a line. And that and 4 others, are the entire thing that geometry is built on. So, will you do proofs in calculus, Matthew? I don't know. I don't know. Oh, speaking of, did I answer the A, B, B, C question for y'all in here yesterday? Calc AB and Calc BC? Okay, I just wanted to make sure.